Now, sometimes when you are adding or subtracting fractions with different denominators, you're going to deal with whole numbers. And whole numbers can be very important because, as you're going to see in this problem, it's not always as simple once you get to that final step. There's going to be a little bit more you have to do in order to correctly solve. So using the same process, for now, I am just going to ignore these whole numbers. I am focused on the fractions because if I am changing my fractions, if I'm changing these denominators, no matter what, this is 3 wholes and this is 1 whole. It doesn't matter if that's 4/4 3 times or if it's 8/8 3 times or 12/12 3 times. Either way, that is always going to be 3 wholes. So I'm just going to ignore it. If I list my multiples of 4 and 8, this is going to be a really short list because you're going to notice that 4 actually would line up with 8 perfectly because 8 times 1 is 8. So right there, I'm going to stop, and I know that my least common multiple is 8. This is going to make things a little bit easier when I do my second step. So as before, I'm going to have my setup 3 2/4 minus 1 7/8. Okay, I'm going to multiply, 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 fraction, fraction, equals, equals. I'm going to scoot it down a little bit, fraction, fraction. Okay, my lowest common multiple shows me that my new denominator is 8. Okay, now 4 times blank is 8. I know that 4 times 2, write my 2 up here, 2 times 2 is 4. This now turns into 3 4/8. Okay? Now down here it's even simpler because this is already in 8s. So I'm just going to multiply 8 times 1 is 8. Same thing up top, that's actually going to stay the same. So this now turns into 1 7/8. So my new problem is 3 4/8 minus 1 7/8. The issue here is if you're trying to do this in your head, you cannot do 4/8 minus 7/8. So what you're going to have to do is break off one of these wholes and add it to your fraction in order to make it possible. Now, there are 2 ways you can do this. There are 2 methods you can use. Both of these we have learned in class, and whichever one your child prefers is fine with me. So we have, let's see here, 3 4/8 minus 1 7/8. Okay, so first way you can do this is to switch these mixed numbers into improper. And I'm actually going to write these down a little bit so we can see that a little bit better. 3 4/8 minus 1 7/8. Okay, so if you remember at the beginning of the year, or if you want to look at the previous videos that I have posted, one quick, easy way to change this into an improper fraction is to multiply and then add. So 8 times 3 is 24. 24 plus 4 is 28. And then I'm going to keep my denominator the same, so that turns into 28/8. Still subtracting. 8 times 1 is 8, plus 7 is 15, so this now turns into 15/8. So now I have a much simpler problem. 28/8 minus 15/8. I can do that in my head. That is 13/8. Last thing I need to do, going back to our first lesson as well, is I need to convert this back. I cannot leave my answer improper. So if I convert that back, my answer is going to be 1 whole and 5/8. Okay? That is one way to do this. The other way is a little bit shorter, but it is kind of tricky to remember where to do what. So whatever way you prefer is fine with me. So once again, I have 3 4/8 minus 1 7/8. The way you want to look at this is I'm going to break off one of these wholes over here, and I'm simply just going to move it over into the fraction. By doing that, I'm going to make this fraction bigger than this one, and then we can just simply do it in our heads. So I'm going to subtract 1 whole, which would give me 2 wholes left over. And since I look at this fraction, I know that my denominator is 8ths. I would know that 1 whole would be 8/8. So I'm going to add that to this fraction. So 4/8 plus 8/8 is 12/8. So now my new mixed number is 2 12/8 minus 1 7/8. And then I can just do that in my head. 2 minus 1 is 1. 12/8 minus 7/8 is 5/8. Same answer, just a different way to get to it. Whichever way you prefer is fine, just make sure we get there eventually.